Hello, everyone. I'm Vladimir Suparev, and I'm the VP of Cryptographic R&D at InfoSec Global. And today we're thrilled to have Nick Sullivan, a leading cryptographer and technologist, join us. Nick, thank you for coming to our show.
Happy to be here, Vladimir.
All right, great. So I think it's great to start with just giving a little bit of background about yourself so our audience know who you are and your background in terms of the cryptographic world.
Sure. I've been involved in the technology world, working with cryptography for about 2 decades. Most recently, at my own consulting company, where I advise companies on different aspects of new cryptographic technology and software, hardware, these sort of things. And previous to that, I worked at Cloudflare, where I helped push forward the idea of cryptography as a tool for securing the internet. Managed to do quite a few interesting things at Cloudflare from a cryptography standpoint, whether it's through research, through implementation of new ideas and new projects, to deploying standards and working with standards bodies. So folks may know me from a number of different things. I do write blog posts. I've written quite a few introductory and explanatory blog posts about cryptography on the Cloudflare blog and Ars Technica and other places like this. But for me, I find cryptography to be a near magical tool. It enables capabilities for people that you really can't get with any other technical tool. The ability to limit how information is distributed and take the idea of taking a lot of data and reducing its security down to the size of a really small key. And as they say in cryptography, cryptography is a transform that changes systems problems into key management problems. But that's sort of a story for another day. And so, yeah, so I worked previously at Cloudflare. I worked at Apple doing cryptographic protocols and a lot of different things related to securing content. And prior to that, I did my education. I have a master's in cryptography as well as undergrad from University of Waterloo in pure math and combinatorics. And so, yeah, I'm part of this cryptography community, which is an amazing group of people trying to use this technology to help improve security in the world, privacy in the world, and help businesses make the right choices security-wise using cryptographic tools that are available.
Sounds amazing. Sounds amazing. And your reference back to University of Waterloo, especially the CNO and pure math department, seems like quite often, if you pick up a cryptographer, there's going to be a high chance that they'll have, something related to Waterloo and something related to the CNO department for the crypto, or for where they started their crypto or their interest in crypto. Talking about your Cloudflare experience, so back in October of 2022, Cloudflare started preparing for post-quantum world early on using experimenting with some of the post-quantum cryptography. And Cloudflare has enabled specifically X25519 plus Kyber-based LMChem to work together and basically for all their websites and APIs. It's a beta version. And is there a reason why specifically these two algorithms were chosen and why they were chosen to be in a hybrid mode rather than purely post-quantum mode, etc.?
Yeah, so the transition to exploring new post-quantum cryptographic concepts and key exchange algorithms inside of the web context, it mostly boils down to TLS. This is the security protocol that secures websites that start with HTTPS. And for the most part, that's almost every website now. Couldn't say that 10 years ago, but for the most part, when you're connecting to a website, you establish a secure connection using TLS. And there's been a lot of evolution in this over the last little while. TLS has evolved and changed in different ways. It's gone from TLS version 1.2, which is effectively similar to the versions that were derived and implemented back in the 1990s with what was the SSL protocol. But there's several components to TLS that are relevant cryptographically. There's digital signatures for the website authenticating itself to the user, saying, hey, I have control of this domain. And then there's a key exchange mechanism to establish a security key so that everything can be encrypted in both directions. And then there's an encryption key, and you use that to actually encrypt the data. And so exploring how to evolve this system in the context that I expect us to go into pretty soon in this conversation, but the context in which the whole industry is attempting to find a path to take the existing types of cryptography that are widely deployed, RSA, finite field, Diffie-Hellman, elliptic curve-based Diffie-Hellman and signatures, which are potentially vulnerable to this attack that can be enabled by quantum computers called Shor's algorithm. This is something that doesn't exist yet at the size at which it would need to exist to break this cryptography, but the idea is that quantum computers are coming. They're being developed. They're growing at exponential pace in terms of how much computation they can do, and eventually it'll get to a point where this cryptography, this classical public key cryptography that we've had since the 70s and 80s, is vulnerable to computers that can potentially break it. So the exploration of what we could do to swap in or use different algorithms that may be secure against Shor's algorithm is a very long process, and it's a very challenging process because this is the core to almost all cryptographic security that we have in all of our systems and the internet and everything online. And so there's a number of ways that individual companies could choose to address this. And when I was at Cloudflare, it was relatively early on in the transition to exploring these new post-quantum algorithms. So there was a series of experiments that were done ahead of time to help inform the standards process, which is sort of choosing algorithms. So for some background, NIST, the National Institutes of Standards and Technology in the United States, has put on this process for helping decide which different post-quantum algorithms to standardize. And there's multiple tracks here. But at the time that we started exploring post-quantum, there was still a whole wide variety of potential algorithms that were in the running for being the NIST-validated, NIST-certified algorithm. And so whether or not we would use any particular one of these came down to, first, the cryptographic security, which is something that we didn't have the full set of abilities to vet this in-house. So, trusting and contributing to the public process where cryptographers are submitting and reviewing these cryptographic algorithms. But what we could contribute to is understanding the impact of deployment. And that's beyond just the inside of the cryptographic box, but it goes to things like key size, time, computation time for things like key agreement mechanisms, and what is the size of what does it do to protocols? Like if you take a current set of keys that are pretty small, like elliptic curve keys, definitely 64 bytes and under, to like one of these post-quantum keys that might be a lot larger. And so what we started to do was to explore what would happen if these differently shaped algorithms were put into TLS and put into and run on the internet. And as much as the internet seems like a black box, there's definitely a lot of interesting challenges to deploying protocols on the internet. TLS is standardized, and people agree on the ways to do it, but there are different implementation quirks and issues on the network level all around the internet that mean that every upgrade has to be done slowly in order to make sure that it's not breaking things. And so first, I don't remember the exact year, but we first started experimenting with Google Chrome, who's a large browser. They have a very big percentage of the browser market share. As a natural partner, where Cloudflare is operating the front layer for websites, sitting in front of websites and performing the TLS security handshake and all these sort of things. So with a big percentage of the internet using Cloudflare and a big percentage of the internet user base using Google Chrome, we could carve off a small experiment to see how these things would work. And so we started with different versions of public keys. And you asked the question of why did we do a hybrid versus like an individual post-quantum. I think the goal was here we're experimenting with new technology. So the idea of swapping out something that's tried and true, like elliptic curve Diffie-Hellman, for something that may have problems that we don't fully know about, seemed too risky, and it potentially violated the security guarantees that customers were expecting from a TLS implementation. So the way that these experiments went with Google Chrome were that we would use the existing key exchange mechanism and then add an additional key exchange mechanism for the post-quantum bits, and then use hashing to bring them together into one handshake. And so this sort of evolved. We tested with multiple different candidates. There were these lattice-based candidates that were very large keys, large public keys, large values that would be kind of blow up the key size tremendously, but were very quick computationally to use. This includes like Kyber, which was selected by NIST as MLChem, as sort of one of the blessed key exchange mechanisms. And then we explored another category that had much shorter keys, more similar in size to the keys that we're used to, but had a larger computational burden. And so after deploying that, we had some feedback that the computation cost is actually demonstrably relevant to users. In the case of the small but heavyweight key, in this case it was called Psych, since been mathematically challenged as well as implementation challenged. But this feedback to NIST helped refine and give some feedback to the world as to what's been happening. And this is a long story, and I'll get to your answer to your question now. And so as these sort of algorithms are selected and people coalesce around what the right thing is to do, it really boils down to standards bodies and implementers making a choice as to what is a code point that represents a specific implementation of a post-quantum hybrid algorithm that you can use to swap in with the current TLS handshake that's not post-quantum secure. And this is something that is up for very great debate. It's being debated right now in the TLS working group at the IETF, the folks who help define protocols. And in the meantime, Cloudflare decided to go with the algorithm that it was very close to being selected by NIST, not finalized yet, in conjunction with an algorithm that was most popularly used before. So elliptic curves with curve 25519, Diffie-Hellman, and this Kyber lattice key exchange mechanism, and sort of putting those together and giving it a code point so that it can be negotiated between client and server is sort of where it's at today. This is not necessarily where it's going to be at the end of the day once we've matured this transition to the point of a large percentage of the internet using it. The number of people using this new key exchange, which is implemented on certain versions of Google Chrome, and on Cloudflare for a large percentage of the sites, is actually a very high number of connections. I believe the public numbers, don't quote me on this, but according to Twitter, is somewhere on the order of 1% of handshakes are within Cloudflare, and customers are using post-quantum secure key exchanges. And so the idea is this is as close as what we expect the standard to be right now. So we'll use this code point. And once the various standards bodies come up with blessed final versions, the world will migrate to these. And this is what we hope, because standardization and using the exact same technology across the entire industry is not a given. It's sort of an effort. Involves compromise, getting different organizations who have different requirements to kind of agree on a general shared implementation or a shared set of rules for negotiating post-quantum. So this is, it's a long process, and it's been at least 5 years since Cloudflare's been experimenting with this, and it's been pretty successful so far. I think the migration to post-quantum hasn't shown too many large hiccups. There are some issues with deployment regarding the large keys, but not dramatic ones, not ones that would cause 1% of connections to fail or 5% of connections to fail or things like this. We're in the margin of error with respect to where in the internet these large keys can work and can't work. And so that's just TLS, right? The entire industry has to do the migration for every other system that uses cryptography. But yeah, no, when I was at Cloudflare, I was very happy to help contribute to the standardization work and to help get post-quantum deployed for users really early. Because at the end of the day, the main risk for cryptography, post-quantum cryptography on the web, is this idea that current plain text could be decrypted in the future once the technology evolves to the point of being able to retroactively decrypt it. So it's the there's a lot of terms for it, but it's the gather once, decrypt later paradigm of a threat model, where you're assuming that the network is secure, or assuming that the network you're not assuming the network is secure, but you're assuming that that the network is able to be copied by an attacker of one sort or another, like a transcript of an encrypted connection, fully copied down and written down and saved for later, and then you can go back and break the keys and decrypt the content, as long as you can break the cryptography, which, as we know, as of today, is not possible with current quantum computers, but is theorized to be on a short-term horizon of something that's coming.
It's been amazing. And, technologically, all of this makes 100% sense to me as a cryptographer, but the question I have in terms of the follow-up, right? So when you think about a C-level executive who we need to get an approval to work on that project, first question that might come up, CRQC is not here. Cryptographically relevant quantum computer is not here yet. Second of all, is this quantum threat real? And all these sort of questions start coming up, right? And third of all, even if we talk about, Kyber-based schemes, for example, MLChem, we know it's the FIPS 203 document, which is not even finalized yet, which means there is a high chance that you will need to modify again what you've done. So I guess my question is, not from technological point of view, but more from logistical, how did you get a C-level buy-in, and how did you create the PQC task force to work on that project?
Yeah, and I'll say that I love my colleagues at Cloudflare. I think they're very forward-looking in terms of implementing new technology. And this post-quantum transition was something that the folks on the team who are connected with the cryptography community were aware is coming to industry, right? And Cloudflare's product helps improve the security of websites in a way where you don't have to configure it a lot. You don't have to do much fiddling of buttons or anything like this. It's sort of a smooth upgrade process. And so it was, well, it's relatively easy to convince people that or to convince people that this is a good idea of something to pursue, right? It's a risk that's sometime in the future, and it's a risk that is high profile with respect to the news media in the current day and age. There's, every month there's a new post-quantum or quantum computing article coming out with sometimes fear-mongering, sometimes claims, but in any case, it's very top of mind for folks at the C level to read these articles and ask themselves, what is my company doing to prepare for this? And Cloudflare was in the position of having cryptographers on the team, having specialists who really know how to dig deep into the network layer to put together a group of people to look at this. And so I provide recommendations. And after looking at the recommendations and doing some experiments with folks like Google, it became clear that Cloudflare could be a leader in this area and be sort of first to deploy. Cloudflare was also one of the earliest companies to deploy TLS 1.3. And so from like a C-level perspective or looking at presenting the company to the world, this is showing innovation. It's showing leadership within the industry. And it's also showing a commitment to customers, because getting out new technology to customers as early as possible, especially customers, there are millions of customers that use Cloudflare that would get this security upgrade for free. And because of the nature of post-quantum cryptography, because of the nature of the types of attacks of collecting once, decrypting later, as long as everything is continuing to do things in hybrid mode and use existing cryptography, you can make all the security claims that you could before post-quantum. And so trying different post-quantum keys that may or may not be secure from like a mathematical sense only adds additional security to these connections against this type of attack. So there's that. I think another big aspect of how we were able to do this was just the company's mission to help build a better internet. This really aligns with that, like trying to build a more secure internet, and to take technology like this and democratize it in one way or another, so that at least the baseline level of post-quantum security is something that everyone would have access to through Cloudflare's inexpensive plans. And so to go to your question of the task force, it's not too much inside baseball, but I think folks are aware that most companies that have a wide variety of customers across industry and government know that there are certain types of certifications that you need to have for your business in order to sell to, say, the US federal government, for example. And so in working through these certifications, there's definitely aspects of this that involve accounting for cryptography. And so the migration to post-quantum cryptography was vastly accelerated by the company's commitment to getting FedRAMP certification, which requires certain controls around cryptographic aspects. That helped the company get a very complete catalog of where cryptographic components were being used within the architecture. Sometimes that's difficult, even for someone engineering within a company, to be able to suss out and understand. But also, it puts you in a position to have folks across the different parts of the company, whether it's aligning with marketing or aligning with like public statements from the executive level, to having engineering and having like security and compliance all kind of aware of the map of where things are, so that when you propose a plan to upgrade, several dozen systems to use experimental new cryptography, there's a level of documentation and comfort and support from the other folks within the company. And I think the mission alignment is a big one for companies that are sort of less ideologically aligned to, let's build better things for the internet and make them affordable. And companies that are more oriented to, yeah, we need to secure our customers' data, or we need to secure our services and whatnot. The argument can be a little bit more challenging, but the main points still stay. You're able to say publicly, like, that you're involved in this innovative new security direction, helping put your customers first in terms of this long-term quantum threat. And it also can be, as I mentioned, being able to document and have a good understanding of where cryptographic components are used in your system is valuable for large engineering changes that have to happen within an organization, or things having to do with meeting certain certifications. Having that expertise in-house is extremely valuable for what is to be expected to be a number of different migrations, either in the cryptographic post-quantum world or within the software world in general. So you don't necessarily need cryptographers. Cloudflare had cryptographers to work on this sort of thing, but the other folks who are impacted by these type of systems, and it's from engineering to operations to even cost. You have to actually account for the cost of the additional bytes on the wire and the CPU cycles and all these sort of things. All these folks can be looped in and should be. And if this becomes a top line objective for the company, it's hard to in any company prioritize what's important. But the benefits of having more agility inside of a company with respect to cryptography is an excellent way to position a technical infrastructure for new changes that happen. And it's a great thing to tell your customers is, these aspects of the system were classically secure. Now they're post-quantum secure, and this is a huge benefit to them in the long term, assuming one of these computers actually is built.
Yes, agreed. Yeah. So when you say something that is, futuristically secure in a sense, it almost sounds a little bit sci-fi, although this is the reality. We're saying, well, to the technology known to be even built in the future, we're already secure against that. So that's quite an amazing story for, to tell a client. Now, one of the other things is that you're a co-chair of Crypto Forum Research Group, or more commonly known as CFRG. And I was just wondering, from the inside of the group, members, like, what are their thoughts about the quantum threat to cryptography? Are they addressing it as a big threat or something that is routine in a sense? So what's sort of the level of approach to that?
Yeah, so the CFRG is a research group within the IRTF. There's a lot of acronyms. It can be a little bit confusing and difficult to join into, but this is a sister organization to the IETF, the folks who help write the internet standards like TLS that I mentioned, things like HTTP or SMIME, like email, basically any fundamental protocols on the internet below the web layer are defined by the IETF. They have a group, the IRTF, that does more research-focused work, still publishes RFC documents. The Crypto Forum is one of these groups, and it focuses on giving advice to the IETF and folks working on internet protocols as to how to use different new primitives as they come out, or recommendations for how, like, specifying new types of algorithms that are of interest to the IETF, or general advice on how to write your cryptographic APIs. Or there's a lot of different layers in which the CFRG contributes. For the most part, they publish specifications of cryptographic algorithms that are not specified in the same way other places. So, elliptic curves 25519, I think, were first specified within the CFRG as an RFC, and then later were adopted by NIST and some of these other standards. So in a way, CFRG is sometimes a little bit of ahead, but it's an advisory organization for the IETF. And I would say from the perspective, like to the question of what does the CFRG think about this quantum threat and post-quantum, I think the opinions are mixed. Crypto Forum is a collection of volunteers, and anybody can join the mailing list and contribute their opinions. There are numerous really well-respected experts within this group, and there's debates, right? I think there's folks who want the effort to specify these algorithms and decide to go faster so they can be deployed. Other folks have the opinion that this is not a pressing need for 2024. And so as co-chair of the group, I really have to help the output of the group align with the interests of the folks in the group willing to do work. Again, it's a volunteer organization. Oftentimes companies sponsor folks to work within this, but other times it's people working on an individual capacity. And to work towards things that really have consensus as a real problem. So most recently, this question and the question that you asked me about, should we use hybrid? How do we do hybrid? Should we use just post-quantum? That's the sort of question that I think the CFRG is in a good position to provide some feedback and input on. And there was an adoption call for a topic to write a document for helping clarify best practices around hybrids. But overall, I think CFRG follows the interests and the direction of the participants of the forum, and is guided by what's most important for internet protocols within the IETF. And so it's an active discussion. If folks want to see an active discussion in the standard space, subscribe to the CFRG mailing list. And there's a lot of really deep, sometimes contentious, but ultimately productive conversations that go on there.
Sounds great. So going back to the harvest now, decrypt later attacks, which you mentioned earlier, just estimating or thinking about it, what percentage of data that is encrypted and sent today do you think is actually vulnerable to that attack today? Like we can assume today, not a year from now, not a year ago, but assuming that at this instance of today.
So the question is, how much of the data, and this is data sent over the internet or just data used in business, which is a potentially larger amount?
Well, I guess we're trying to figure out a percentage, right? So I'd assume that it's data that is sent mostly over, I would assume it would be roughly the same percentage, whether it's sent over the internet or if it's sent within a business. But again, the initial key establishment would be happening by classical so-called public key methods.
Yeah, this is a question that's very, very difficult to answer. I feel like it could be a fun old school Google interview question that they ask for consultants, like what percentage of the internet traffic in the world, or you could just ask how much traffic is there over the internet in the world. And without the statistics sitting here, I couldn't give you a good estimation. I will say that a lot of folks don't have a good understanding of how information flows across the wider internet and how different networks are connected and how data is protected across these infrastructures, let alone which of these fundamental pieces of internet routing infrastructure are capable from like a computational perspective and a storage perspective to collect data and store it long term, whether they're capable or whether they're doing so, right? The internet is truly global, is operating in every country. A lot of the times when you're going to a website, you're crossing over international boundaries, and there's people store a lot of their data within cloud data centers that are located in the US or in Europe or closer to the individual users and eyeballs through edge networks. So it's really complicated how much data is going out and about and around here, especially with things like CDNs and local caching, where the actual distance over which the information travels might not even extend beyond a city, right? If you have a local copy of the website within a data center in the same city, depending on how routing goes, your data might not even cross state lines. It might not, it might not cross international boundaries. And then you have other countries, like in Brazil, for example, there's not a lot of interconnection. So if you're going to go from one network in Brazil to another network in Brazil, sometimes you connect through Miami, and then you have to, go send the data on the pipes up through the Atlantic. So I would say that it's really complicated to get an estimate of what data is at risk across the internet, but I will say that it's not zero. And large data centers with massive storage capacities exist and are being built, not only by nation states, but by private companies. I think the harvest now, decrypt later attack is often conceived of to be one that's operated by a government of one type or another, instructing companies to collect data on their behalf, or adding in particular hooks to it, which leads to a whole new set of assumptions with respect to risk, right? There's protecting your data against hackers, against people using it maliciously, and then there's protecting your data against, foreign and domestic government actors. And so these all have different concerns and different constraints. But what I will say is it's very, very possible to collect a large amount of data, including very targeted data, because encrypted data is sent over the internet, right? And it's sent almost indiscriminately across different aspects of the internet, different international borders, different exchanges, because of the way that people think about data. As if data is encrypted, then it's no longer really bound to be viewed by wherever it goes. So it's sort of trusted to follow different paths to get to different locations around the world. And so this is starting to be challenging for folks building businesses in Europe with the new privacy regulations about keeping data in the EU. Similar privacy regulations are happening in other places. But at the end of the day, there's a lot of data that goes over centralized exchanges, and the encrypted data at those exchanges, there's a lot of folks that have access to it. We're not talking like tens of thousands of organizations, but like within a given exchange, there's a lot of access to encrypted data. So I would say that for the most part, almost all data that goes over the internet over a reasonable distance through multiple networks is potentially subject to this attack. How much of the data today is actually being captured and stored? And is that done in a selective basis or a broad collection basis? I don't know. I'm not part of the groups who would be collecting this, and the folks who are collecting this, I don't think are advertising that they're doing so.
Thank you for that. And what if somebody's starting, or an organization, let's say, starting their quantum safety migration, let's call it this way, what do you think should be the first step, the first fundamental step they should take in that migration process?
Yeah, the first step is cataloging your assets. In order to transition your technology, you have to understand which pieces of technology you're using and which smaller units of technology are they relying on. You'd be surprised how many different versions of OpenSSL an organization could be using, or how many different, if teams are using open source cryptography from other places or open source libraries. Companies are built with open source software, and yes, this you need to track this internally to make sure that the licenses are being respected, but having a good catalog of which products you're using, which pieces of software you're using that are sourced from outside or built in-house with libraries is the very first step. You can't make a post-quantum transition without having an understanding of where your risks are. Not only cataloging it, but also looking at what's the biggest risk to customer data. So if you are talking about a connection between a database server and backend server that are running in the same data center on a cloud infrastructure, and they use TLS to connect to each other, that's sort of a less of a risk than an endpoint that's an API that's available over the internet, where it could be more easily collected over the open internet versus less likely to be collected within, say, Amazon or Azure or GCP's infrastructure, because the data doesn't hit the wide internet.
So doing crypto inventory seems to be the first logical step to do when you're looking for quantum vulnerable cryptography to understand what you're going to migrate. And at the same time, we understand that this is going to help us find other vulnerabilities that are vulnerable basically today in terms of the classical world. Another topic that is quite often heard in a PQC migration, although there's no concrete definition of it yet, is cryptographic agility. What is your definition of crypto agility?
Yeah, I mean, I think cryptographic agility is one of those terms that has gained different implications based on the context it's in when it's used. Traditionally, within protocols, cryptographic agility just means the ability to change a single signifier and swap out one piece of cryptography for another. It's about compartmentalizing which aspects of a protocol are cryptography and which are not, and taking those compartmentalized pieces and making them into a shape where you can swap something in or out. And so this has manifested itself in a lot of ways. In older versions of TLS 1.2, for example, there were tons and tons and tons of code points you could use to represent different combinations of types of cryptography, and that was considered agility. If one cipher suite is preferred, and then it's discovered that it was incorrect or has a vulnerability, like happened, say, around 10 years ago with ARC4. The RC4 stream cipher had some bias issues that were implemented, and so you could just, in an agile way, as a client and server, deprioritize the ciphers that are problematic. And so this sort of led to added complexity, so having too many choices. But I mean, I think the real fundamental goal of agility, and my definition would be the ability to move quickly in the case of a change in the state of the art of the understanding fundamental cryptographic primitives. So if you want to be able to change something that is currently being used and currently was considered secure or valuable up until a specific point, and being able to, without a software change and just a configuration change, and without changing the API or the architecture of the application or the software, to be able to upgrade the cryptography. And so having a good abstraction layer between the cryptography and the protocol, and a good way to manage that from an administration point of view is that's where I see agility's definition, and this is where I see it fitting into different things. So for example, TLS 1.3 has several points of agility. It's separated on signature, on key agreement, and then on cipher for the data, and being able to change these based on not only on which cryptography the component you're talking to speaks, being agile to move across different versions and be compatible with different implementations, but the ability to deprecate, I think, is another big aspect of of cryptographic agility. And what we learned from TLS 1.3, or what we hope from TLS 1.3, was that it's if you have agility, it's best to have agility between a small set of very good options rather than a large set of potentially risky or dangerous options, and that giving developers the chance to make smart choices, to be agile with their software without accidentally implementing something that's less than ideal. Yeah. So, what is your general perspective on the urgency of PQC? I've heard a lot of experts, and I sort of shared with you how the CFRG has various views on this and the relative importance. But from your perspective, is it important to look at the transition now? Is this something that all companies should be doing? Only certain companies should be doing? What's your perspective on this?
So my perspective on this is that we should have started PQC migration, as I usually mentioned yesterday. The reason being is that a lot of times organizations are falling late because they think that what they need to do is go ahead and change the crypto. Realistically, that's 2 steps ahead already. You need to go back 2 steps, and first step is to understand it. So there is actually a learning curve to this, to understand what is the threat. I mean, there's going to be different professionals out there that need to understand it at their own level, but there needs to be an understanding. This is something really new in the world that is coming up, and that's something we'll have to experience. Second aspect is also, as we've discussed, about crypto discovery. That phase needs to run as well. That's a full phase. That's quite a lot of work as well that needs to be done. And thirdly is actually changing cryptography. Now, we know that it's actually complicated to change cryptography, especially if there's no crypto agility in place. We know SHA-1 to SHA-2 took 5 to 10 years for large organizations to replace. So therefore, regardless if we believe CRQC is going to be available in 5 years, 10 years, etc., we understand that this is a very long process, which we need to start as soon as possible, hoping that we will finish it in time. So I think we're already past the line where we can kind of firmly say, we're going to make it in time. I think we've passed that timeline. So that's why I think there is actually a higher sense of urgency right now to start getting into the field if the organizations haven't started that, regardless of the size. I mean, of course, there's different levels of risks associated to various organizations, but whether or not, they're planning to do this, this is sort of a given reality now. PQC migration needs to happen. It's being standardized by NIST. There's a lot of initiatives around it. There's White House memos coming out on that topic, etc. So the migration will need to happen. And, again, our hopes is that it's going to happen. The migration, most organizations will be able to complete that migration before quantum computer threat is going to come. And the reason why it's important to say before is that, let's assume, a scenario that tomorrow somebody says CRQC exists. This is going to be devastating. This is not like organization not having migrated from RSA to ECC or even SHA-1 to SHA-2. I mean, You're not doing RSA to ECC or SHA-1 to SHA-2. You might be losing a little bit of security or a little bit of performance. CRQC is going to devastate over 90% of cryptography. So this cryptography that is used, I mean, again, if we're talking about the symmetric part, we know the keys a lot of times are coming from asymmetric part of it. So that means in that case, they become vulnerable as well.
Yeah, I'm really fascinated to see which organizations are choosing to become early adopters and leading the way, and which organizations are behind, and sort of what motivations they have with respect to prioritizing this, and seeing different trends in different industries based on, exposure and security awareness, just general computer security awareness, because digital cybersecurity is an element of every business, and choosing which aspects of it to prioritize or which aspects to even be aware of is a challenging thing in its own.
Great. Nick, I really want to thank you for your time today and your great insights and the conversation. It's amazing to talk to a cryptographer who is actually looking at it from research perspective, from industry perspective, from government standardization perspective. It's all these 3 components that are coming together that actually form the full view on the whole cryptography and this upcoming post-quantum, upcoming already started post-quantum track that we're seeing in the cryptographic world right now. I mean, it's the biggest cryptographic change we're yet to see in history, which is quite amazing. And it's great talking to you and hearing your insights. And when we have conversations like that, I think our pictures in terms of what needs to be done, where we're at, are becoming more formatted in a sense, and something that we can start prioritizing or figuring out what the strategy should be, so that way, we increase our chances to be cryptographically secure.
Yeah, that's a great summarization, and thanks for chatting. I had a great time.
Great, and thanks everyone for watching. And if you would like to find out more information about cryptographic agility, cryptographic inventory, feel free to visit our website at infosecglobal.com. Thank you very much.